Hi, I'm Clark on Temptress. Today we're going to talk about homemade batteries, how to build a battery for yourself. Now, drop-ins are getting real cheap, they're getting pretty good, but there's still sometimes when that battery doesn't meet your particular needs. I had that need, I built this. Today we're going to build something very much like it. This is a battery I built several years ago. I built it specially for a mission. The mission was, Emily had just built herself a new boat. She built it all herself. There's a video series on that if you like watching people build things. I built this battery to power the outboard motor, an electric outboard that she had for that boat. And I wanted special things in the battery. I needed it to put out enough power, of course, and I needed it to be very waterproof and be absolutely off when it's off. And if I were to put a bar right across this right now, this is off. Let me just show you quickly what I did. In this video, we're gonna build another slightly different, very similar one, and look into how something like this might be good for you. So inside it, I used these spiral cells. These cells can put out a lot of power. They're not limited to that 1C thing. That's part of the reason I used it. And quite honestly, I used it because at the time they were available and they fit in the case. We usually carry something in this little wasted space. Right now we have a little inverter in here. That's handy. When Emily went out, she would put a VHF radio in there. And then there's this big circuit breaker. And when you turn it on, now these poles are hot. And when you turn it off, the poles are cold. And of course, if anything bad happened, it would turn itself off, circuit breaker. Under the wood here is the BMS and an active balancer and all the things a battery has. So we'll go into that in detail. So this is the old. It's been in service to us for many years. Didn't get used an awful lot on her dinghy because it turns out her dinghy sails wonderfully and rows wonderfully and she just doesn't want to bother. In fact, we sold the outboard to someone that needed an electric outboard. But I've been using it in my lab a lot, and when we had our band, we would use this to power the PA system, and it worked great while we were practicing, in places that didn't have power. We're going to build a new one of these today, and I think it's a cool idea, and you might want one yourself if you have either the need for mobile power or the need for waterproof power, or if you just plain want some portable power. There's nothing more portable and easy to deal with than this thing. So I'm gonna take a little break and put all the parts on the table for the next thing, and then we'll build it. So here's what we're gonna need to do this build. This would be the same for any battery build you did. This video is about a relatively small 100 amp hour set of batteries. If you're gonna make like a 400 amp hour build for your system, it's all the same, just things are bigger. Okay, the heart of it is this, so I'll talk about this first. This is a 100 amp hour battery set. There's 4 cells, 4 100 amp hour cells. They're put in series, so that gives us the 12 nominal volts. Your normal lithium iron phosphate setup for 12 volts. You can do all this with higher voltages, just having more cells in series, and you get a little different BMS. We'll get to that in a minute. The history of this one is someone sent me a battery for review and the BMS was not good. It was designed badly. Battery had all kinds of limitations that I just wouldn't have accepted. I didn't want to just put out a negative review. I figure the better thing to do is talk about the batteries I like, but they had sent it to me and they wanted me to do a review. So I just was honest with them. I said, you've got these problems with your product and you could fix the problems and send me another battery later. I can just not do a review, which I thought was charitable, or I could do the review. And first they said, do the review, because how that goes sometimes when you're dealing with people that only think about instant profit. And I suggested to the woman I was talking to, maybe you should send my emails to your manager and ask his opinion on this. And the next email was, thank you, sir, please do not do the review. So I took up all the parts that I didn't like, and I ended up with this cell pack. And this is actually a very nice cell pack. If the battery were to have been set up with a good BMS, I think this would have been a great battery. It had cold weather protection, the BMS had. It actually has a heating blanket attached to it, and we'll be using that in this build. The cells are nice, and they're placed together with these heat sinks on them and compressed with straps. The heat sinks squeeze all the batteries. Apparently with these prismatic cells, you want to have kind of side pressure on them and hold them together. Of course, they're self-supporting on the inside, but you don't want it to be able to balloon out. They can operate at a little bit of interior pressure, and if you can hold that pressure into shape, apparently under some circumstances, they benefit from that. Well, they did that very well. I can't throw things away, so I had this, and I put it in the case for the last one. I actually disassembled it a little bit and found it fit in there very nicely, just like it was set up for that. So I bought a new case. I bought this on eBay or Amazon or whatever, but you know, if you're in the States, stop by Harbor Freight. They have lots of them on the shelves. It's the Apache 2800. This is just the case I'm using, but you could use any case. And it's just, basically it's a total ripoff of something called a Pelican case. So it's a case, it's very, very waterproof. In fact, it's so waterproof and airproof that they provide a little vent. Anyway, this is a good design for a case, and it's just a plastic molding when you get down to it. So I don't see the difference except the price. So that, the cell, and then the other big thing is a BMS. For this project, I chose this BMS. It is a JBD BMS. This is the same BMS that is in that Elefast battery I did a review on, and I quite liked that. So I thought I would go with this one. The other reason I chose this one is it has a heater function. So when, as you probably know, lithium iron phosphate cells can be damaged in so many ways. You've got to be very careful with them. That's this guy's job. Most BMSs only watch that they hold the cells within a voltage tolerance. Some go a little above and beyond. This one will watch the temperature, and it has temperature probes. And if the temperature goes below freezing, it will stop the ability of the cell to take any more power. So if you try to charge it, it just won't go in the cell. But it has one extra trick. It will actually divert that power through this little pin, and I can run it through the heater. So if it ever got freezing around this battery, this device would actually warm up the cells, and then once they're warm enough, it would click and start charging again, kind of all automatically. Now, if this battery gets the life I expect it to get, it's going to stay in the tropics. That's kind of silly. But if you've already got the wires, why not? If you're going to go up into the mountains with your camper or something like that, and remember, this is just being a portable, you might want to take power anywhere. That's kind of a nice feature. If you had this kind of BMS, but you didn't already have the heater pack, these little heater blankets cost like nothing on eBay. So that's an option. Got the wires we're going to need. I've also got all the stuff that came with the BMS, the hookup wires for the things. We'll go into that in detail. I bought some bronze fasteners. I bought 3/8 inch bolts and nuts and all. Bronze is quite conductive to electricity. So we're going to drill some holes in the case, run these bronze fasteners out and lock them on to the terminals on the inside. And then that'll give us a good place to hook power up to. I'm going to also put one of these little active balancers in here. Probably a silly thing to do because this has balancing. It has, I verified that it works on the other battery. It is a passive balancer, and it can balance the cells within each other at 200 milliamps. This guy can go a lot more. This guy can go over an amp of balance. Like I said, these seem to be good cells. They're already in balance. There should be really no need, but I just want to see how it works. In fact, I'd like to see if it doesn't work, because this is such an easy battery to work on. If I ever have problems in the future, I'm just going to learn something. So I'm going to be putting this into the circuit too. I don't know if I would recommend it. Kind of experimental for me. And well, I think that's all we need. So let's get into it. If you're working with cells, charged cells, of course, they're always charged. Even if they've shut themselves off by the BMS, they still have enough power in them to really, really cause problems. No metal on you. I took my watch off. Just be careful. If I were to drop a wrench right here, really bad things would happen. So keep that in mind. This is not the kind of project you want to do if you're not absolutely confident in your abilities to not screw up. And as I say about opening lithium batteries, if you're not a little bit afraid, then don't do it, because you probably shouldn't be doing things like this. This is dangerous. There is more power in this battery per weight than a hand grenade. That's a lot. This can put out way more power than a welder can put out when it melts steel. That's a lot. Okay, that's the nannying part aside. Now let's have fun. Okay, first thing I'm going to do is drill 2 holes in the battery case for those bronze bolts. Perfect. All right. The battery itself in this build is going to go in this way, shoved right into the corner. The 2 wires coming out of the battery, probably should look into that here first. This wire gives me small wires going to each of the terminals. There's the most negative, and then its positive side. Of course, this is a bus bar. They're the same electrically. For the first positive, as it were. Then the second one. So this is 3-ish volts. This is 6-ish volts. This is around 9 volts, and this is around 12 volts. But with this, any pair of these can tell the electronics what the voltage of the cell is, and then it can do magic to make the cells all balance and all. So that's what this wire does, this group of 5 wires. These 2 big terminals, this is main negative and this is main positive. That's where the actual power comes in and out. And then there's this little heat blanket across the bottom and 2 wires to that. So we'll apply the 12 volts that could be coming out of the BMS to that when things get cold, and we'll put some heat into the system, hopefully warm things back up. Been playing around with it. I think the best place for the BMS is I'm going to put some double-sided tape here and glue that right to that spot, and that'll keep that out of mischief. And then to retain it all into place, probably by rights, I should hold it down in some way. And maybe some double-sided tape would be enough. I'm not going to bother so much. I found with the other battery, it is not an inconvenience to limit myself to say, never open the case when it's upside down. I mean, think about it. It's like a briefcase. You kind of can't open it when it's upside down. So as long as gravity is your friend, you're good. This fits perfectly. So when this is locked down, it doesn't even wiggle. It's just firm. Maybe I'll put a little bit of foam there or something just to give it a little extra. But I do need to keep it from sloshing within the case. And my current thought, I'll probably not do that in this video, but I'll put a little wooden strut in this area to keep it from going this way, and a wooden wall or a strut here to keep it from going this way. And that way I'll still have this area for storage. Unless I put an insulator in, there will be exposure to all these terminals, but all of these terminals are negative. There's no positive anywhere near with the setup. The positive's way over here and the positive pole's way over here. So it's quite safe. There's an exception. This technically is positive, but the way I'm going to solder it, it's just going to be not reachable. I'll have insulation right down and I'll solder from the back. And technically also these wires are positive, but they're locked and protected by the plug that they go with. So that'll be here. That gives us this little area to use for like that inverter I mentioned. Or I think if this goes out, we really like putting the little VHF radio in here. It keeps it all dry and safe and available. Okay, let's go on with it. I'm just going to start going. I'm making this up as I go along. This is not a scripted video. I'm not really good at doing these projects on video. I don't like watching them myself. I know people do, but when I watch one, it's like all contrived. It's like when I was 8 or 10 years old and I did a 4-H demonstration, you know, where you set it all up and you practice it and you have a board and it describes all of the steps. We all know that's not how projects go. We just go for it. We just start doing it. We figure it out as we go. But I think this is going to be pretty straightforward. Let's take a little look at what came with the inverter, with the BMS. We've got this cable. That's that 5-part cable that lets it know about the batteries. And that plugs right into this plug. We have a temperature probe that is an actual thermometer. It can actually read a gradient, you know, real temperatures. That plugs right in here. It says NTC, something temperature. I don't know what NTC stands for, but I verified it goes there. This one is UART, which is a serial connection that's used in electronics. It's kind of like RS-232 at a lower voltage. We won't be using that. That's how you could hook to a BMS or directly to a computer to get all the information. We don't need to because this one has a BMS built onto the motherboard. Here's the antenna for it right here. And then finally there's this switch, and that plugs in here. Now, I don't know if the switch has to be closed to turn it on or opened to turn it on. I can't find it in the manual that is put out with this. It's all in Chinese, but I can't find any section. So we're just going to have to try it both ways. But eventually, I'll probably use that switch like the circuit breaker. So that will turn off and make it all cold. BMSs, of course, have circuit breakers essentially inside them. They're not instant, but no circuit breaker is. Also, there's another mobile temperature sensor, and this one is just a switch. This is, I think they're called bimetallic switches, and there's 2 metals, and they just expand differently. So when the temperature goes, in this case, below a certain temperature, no, for this one it would be above, it goes above the danger temperature, the switch kind of goes click and shuts off. So it shuts off the BMS. We'll just shove that into there because it'll know what the batteries are doing. The BMS itself has another thermal pickup inside it that can watch its own temperature. So if its transistors got too hot, it would shut itself down as well. So we have pretty good protection for temperature, including cold temperature. Please don't charge me anymore. This one is probably also used to transmit the temperature to the Bluetooth app. We have a Bluetooth app. That's pretty damn cool. We have protection from under voltage. You use this battery. It'd be nice to stop it at like 20% for more cycle life, but if you just keep going down and down and down, the BMS will shut down the discharge of the battery before the cells get so low that they can't recover. And that can happen in one cycle. The BMS's probably biggest, most common job is watching the charging of this thing. If you charge the voltages up so that any cell is above a certain limit, this will shut down charging. If you go a little beyond, very little actually, that limit, the cell will outgas, it will pop its vents, and it will die in very short order, just plain drying out inside. Also, the room will smell horrible and it's probably toxic. That's most of what you need to do to take care of the battery, but it's not the important part. Of course, I have that BankManager thing, and the BankManager watches the actual state of charge. It does a lot more, and if the BankManager is doing its job right, the BMS won't have to do a darn thing unless the cells get out of balance, and that's the final thing. The BMS can balance the cells. All right, I guess I put this off long enough. It's time to start wiring it up. The first thing I'm going to do is I'm going to mount this little extra guy, and I've kind of decided I put this little screw in a stud that was available. And I'm gonna put them right here on the board. The back of this board is all insulated. So I'm gonna use a little thermal compound, and I'm gonna basically borrow this nice big heat sink to cool these coils and transistors. And the way electronics works, the limit really isn't how many amps it can flow, it's how much heat it generates. So with this cooling, this thing could just go crazy. Again, experimental. So I'm going to physically mount this, and then I'm going to start soldering everything together. As I hook up these wires that go to the individual cell poles, it's vitally important that I don't cross them. For two reasons. One, once they're finally hooked up, they'll give bad information, and I believe things will actually burn out. And two, these are hooked to a live hot battery. So if I even touch two of them together, I'm going to get, well, it's probably just melt this wire, but don't want to do that. So I'm going to cut one at a time very carefully, because these are metal, so if I cut into two, that's bad. And then I'm going to solder up one at a time. Looks like I have to pull this tape back a little bit. Okay, that's the first. I'm just going to go right down the line now, and I will catch up to you when this is done. Okay, that's all hooked up now. We've got our wires coming in. If you didn't use this device, of course, you just connect the header wires, the sense wires right to the battery, but I'm kind of going through this. What this will do, well, I do a whole video on how an active balancer works, but in short, they're isolated power supplies. The problem with balancing is you're trying to get power out of one of the cells. It's just like overcharge compared to its friends. And if you take power out, that has to go somewhere. It usually becomes heat. This guy can only make heat. It's got resistors. That works, but he's limited. If he tried to draw too much power, it would just get hot and the thing would, become a problem. This guy, being an isolated power supply, can actually take power from the first cell, if it's too high, and deliver it into the next cell. I mean, that's more efficient, yay. The efficiency doesn't matter. What it matters is the thermals. That energy is going somewhere and not making heat. So the thing can move a lot more power because it's not trying to dissipate the heat. Put a little tape on it to make it look halfway decent. It's hard to do tape or things like this on a video without looking like you're don't know what you're doing. Just things don't move smooth on video. Okay, that's a little better. Now, let's hook the batteries up. I guess I'm going to need some more wires. So I'm going to dive down and get some more big wires. I need one more big wire, and then we're good to go. So give me a moment. Okay, got what I need now. This is that thermal blanket. All that is a trace of copper on a piece of plastic that's impervious to heat, and it's just a resistor. So if we apply power current through that resistor, it'll make heat. Back to Ohm's law, got a whole series of videos on that. If you're interested in how electricity works, that's a great place to start. Now, being that it's just a resistor, it doesn't matter what direction we put the power. So we're gonna open one of these wires up, and it's just not long enough for my needs. So I'm going to extend it with this little piece of wire and put a ring terminal on it so we can put it on the positive side. So from now on, that wire will be charged positive, but through a big resistor. By the way, according to the tag here, it's 5.3 ohms is the resistance of that little heating blanket. And they give you some more information. Basically, they're saying at 14.6 volts, it will be a 40-watt heater. I'll leave that tag on there. It's kind of nice. I'm using oversized wire for this need. Never get in trouble with too much copper. And, you know, that's plenty for the amount of power that's going to consume. But to their credit, their whole thing in life here, the device they're making, is to use up power and turn it into heat. So if their wire is a little small, well, what would it do? It'll use up power and turn into heat, so the wire becomes part of the heating. But they actually chose a fine wire for this. You do the math, 5.3 ohms, this thing will probably really be running when it's getting charged at like 13. So 13 divided by 5.3 is, well, it's less than 3. So not a lot of amps going through this thing. Make sure the ring terminal fits. Yep. If you buy these crimp connectors on eBay, or, you know, everything's kind of coming from China now, it's hard to find decent ones. They have such a tiny bit of copper in the crimp area that they just won't hold a crimp. So you have to search around to find someone that's still making something with a little bit of gauge to it. I mean, how much could they really save per unit making that with half the copper? But they do. These have like a shrink thing on them. Oh heck, you know, only gonna do this once. I'm gonna get a little torch and shrink those. Okay. All right, that's seriously overkill. But it shrinks down and there's like some thermal glue, you know, like hot glue inside it, and that all melts, of course. And then when you're done, you end up with a nice strong connection. Probably important because this is a hot wire. If this part of it were to come apart, there'll be lots of negatives in this area. Don't want them getting up to mischief. Okay, so that's that. Let's hook the positive of the battery right up and we'll finish this positive connection. This is all assuming I can find the other bronze bolt setup. What the heck did I do with it? Oh, it's in the case. Okay. We'll want this out anyway. I also have to be very careful because these terminals are charged. I don't want to get any metal near those. I'm saying that to myself, but I guess I'm saying it to you too. Remember, this thing is live. Can't really make a lithium battery dead. If you actually grounded out the individual cells to make it dead, you would make it absolutely safe, but it would never come to life again. So can't do that. Okay, so we're gonna put this on this way. All right. Yep, what I said not to do, I just did. I hope I didn't burn out anything. Well, we'll find out later. If it doesn't work, it's on me. These have to be really tight to get a good contact. If they don't, it gets hot. Feel like such a fool having shorted that. Nothing seems hot here, but I don't know what happened in the board. All right, so we're gonna go through this first, then this. It's hard doing these things on video, for me anyway. I get nervous on video, and then when I can do them on my own speed, nice and thoughtful, I don't screw up. And then you get this idea that you don't screw up, and I'm just not careful enough, I guess, when I'm stressed. And it was right after saying be extra careful. Somehow I didn't think of the wire as being hot. I only thought of the little wires as being hot. Ooh. Okay, now the wrench is gonna be hot. Okay. Now the negative sides. The BMS is labeled B minus and C minus. Very often it's B minus and P minus, P for poles. I think that's a better way of thinking of it. I believe they have the C being charged. Anyway, the B minus goes to the negative side of the battery, and the C minus or P minus goes to the pole. These wires came with the battery that I've cannibalized. I'm just reusing them because it's convenient. They're decent wire. I would prefer they're a little bit bigger, but they're okay. I kind of don't expect... Oh, look at that. There's the burn mark where I touched the wire. Okay, I'm having real trouble trying to figure out what circuit happened here. Because, yeah, the positive touched this, but this isn't plugged in. I think I have to get my meter out. Maybe I have a short in this area. I've got to... Yes, I do. This little stud I put in has shorted negative to this. Right through that trace. Let me get my meter out and see if that looks like it would pose a real problem. The good news is I can now see the whole circuit, and it only went through this. It wouldn't have gone through any of the circuitry in the BMS, so I think my BMS is going to be fine. Now my big question is, with this touching, and I kind of need it there because that just physically holds it in place, will that function? So we'll set this thing for continuity, so it'll beep when we touch. Okay, we're okay. I now have the battery negative connected to the heatsink, but the heatsink is isolated from everything else. And it's floating there for safety, which is nice. But I'm going to have these as exposed as these, so this doesn't bother me. But this is all on me for how I connected this up. And this became a fuse. I melted right through the trace there. That's a bad thing, but I'll fix that. I'm going to solder that back together right now. As I said in these videos and in real projects, things happen. And I really did want to be able to show you what happens when things go bad. This would have gone way worse, except that we created a fuse with this little trace of copper on this deal. I'm a little nervous. You saw I jumped. I swore. It was scary for me because in my mind, like real bad things could happen. And I'm thinking of, can I physically break this wire? You know, if I grabbed it, will I get burnt badly in the process? Where are the scissors? You know, what can I cut with? You should be a little afraid. You should be a little bit, maybe not jumpy. Maybe I shouldn't have had coffee this morning. But these are dangerous. These are very, very dangerous. Okay, it looks like a good little jumper now. And it's not shorted with anything else. Okay, we're back on a roll. And that is off. Okay, well, kind of implied this was going to be a boring fix-it video. Add a little excitement to it. All right, back to this. I gave the torque specs. I forgot them right now, but I remember when I read them, I'm going, okay, that feels about that much, you know. I think it was like 18 pound-inches, which is a lot. That would mean if this was an inch, I'd have to put, no, it was 180 pound-inches, I think. So if it was 10 inches, I'd have to put 18 pounds on it. Obviously, this isn't 10 inches, so I'm putting quite a bit of pressure on this. All right. All right. I think I'll hook this to the battery next, and then I'll plug in the sense leads, and then we assemble everything. Emily, dear, would you get me some double-sided tape, particularly the foamy kind? Thank you. Okay, I guess the final wire to hook up, again, back to soldering. I'll turn my iron on. Big solder, turn it all the way up. Is this one is going to the heat terminal on this board. Isn't that interesting? The other one was red, this one's black. I mean, like I said, it doesn't matter, but this is the negative side, so I guess I hooked it up right. There it is. Okay, we want a good amount of solder on these pads because this one's going to pass that 3-ish amps. That's not that much, really. Okay, we'll power up the board. All right. Should be hot, and if it is, I should have voltage between here and the positive terminal. And yay, I do, 13.25 volts, exactly what the battery is. So it's functional. Now we just have to tape it into place and hook up the negative terminal, and then we're basically done. All right, it's official. The hardest part of this whole project was getting the backs off the double-sided tape. And here we go. Last bolt in. I'll put a little wire tie, hold these wires down. What's left? Well, we've learned that with these wires separate, it's on, so we're going to try the switch. But before that, let's take the thermals and put them in place. I decided just to shove them in to the heat sink here. I think that's a grand place to see if things are getting too hot on the batteries. Can't get it between the batteries. And for this one, I'm going to go down here as far as I can, because the heating blanket is at this end. So if we move it way over to this end, the better chance the whole battery will be warmed up again when the heating blanket is doing the work. Okay. Fasten that up. I want to get that out of this joint here so it doesn't get closed in. I'll do that later with some more cable ties. I don't have any out. I think that's good for now. Let's see how this switch works. Okay, so we have 13.24 volts. And when I make contact with this switch, what happens? Absolutely nothing. I guess there could be a capacitor involved. I have to put a load on that to know. And I got a little load here, an 8 ohm resistor. So burn a little bit of heat. Voltage went down to 100th. But no, that's not it. Okay, that switch does not seem to function the way I wanted it to. I guess I'll probably take like the big negative wire and add a circuit breaker here later. But for now, we got a good battery. So let's, oh yeah, let's fire up Bluetooth. We have a battery. Short of wing nuts, I'll just steal the wing nuts from the other. Oh, I haven't tightened this one down yet. Oh, stupid me. Well, I'll do that in a minute. I'll do that off camera. But this is how you would use it. You put your terminal on and lock that down. But the cool thing now is we can go into Bluetooth and see what we find. I've already loaded the app because I had an LFast battery here I did a review on, and it's the same one. So it should find it. This is all live. Hope this works. Shut up. I'm showing 2 candidates. I think this is the loudest one. Okay, we've connected. It says it's 13.3 total volts. No current, but I'm about to test that right now. Make sure I get this right. This side, it's a bad connection, but I'm only going to put 2 amps through it, so that'll be fine. And I got hooked to my bench power supply. See if it's the right battery. Battery is taking 2 amps. Yep. And it's now showing a current of 2 amps, 1.9, close enough. So this is being fed. This is definitely connected to this battery, no question. And the maximum difference in the cells is 0.031 volts, which is a real small amount. It will be a small amount because we're in the middle of charge right now. The battery's down 25%, which is probably where I left it. This is working fine. Anyway, if you want to know how the BMS works with this app, just go to my LFast video because I go into that in detail. That's where I figured it all out. It's the same app, same thing. I think we've got success here. This battery is taking a charge. It's connected to its BMS. It is connected. I'm not going to run it through all the cycles of tests and everything because you can't buy one of these. So there's no sense having a review of it. It's just whatever I did. I'm going to do one more of these. Another battery that came in. This one was absolutely fine, but I did something bad to the battery. I, again, dropped something and touched something. I got it through the test, but I've decided that I want to use this battery in a different way. So I bought a different BMS from a different company that seems to be like the best. Everybody seems to love it. I think it's JD is what it's referred to as. But we'll do one more of these build-a batteries, and this will be a more classic case type battery, 200 amp hours, and the BMS will be a 200 amp BMS, so it will be a good piece of gear for someone's boat. I guess that's it. Thanks for watching. I hope you like these, me figuring it out along the way type videos. If you do, please tell me in the description. That's how I know what to do. If you haven't subscribed yet, please do. Look at our old stuff, especially if you're interested in this. We have this playlist called the Masterclass. I'm still filling it out. I'll be adding more to it, but it's a good basics in how electricity works. And as I promised, I'm going to do it fairly soon, which might be in this year. I'm going to show you a really great trick for finding a problem in an electrical system that's installed. That's what I was building up to with this whole series. Just as a last note, I'm charging this right off the bench power supply. That is set to only charge to a certain voltage. It has certain protections. But this is no way to charge a lithium battery. So final little commercial from Emily and Clark's Adventure. Go to emilyandclarksadventure.com and take a look at everything about the BankManager. It is the right way to charge lithium batteries for the longest possible life and lots of other advantages. Okay, I guess that's all from me. Bye from Clark on Tempest.